السلام عليكم ورحمة الله وبركاته. Today, inshallah, we have exam October-November 2023, variant 3, paper 6. Let's see, the first question is talking about what? Sand is a granular material composed of very small, irregular shaped mineral particles. A student determined the density of the sand by two methods. So I have two methods now. Let's see what happens in the first method. We have, let's see the diagram. We have measuring cylinder, we have sand, we have bench, to pan balance to measure the mass, and we have bench. According to the drawing, we have two masses. We have 76 gram and we have 219 gram. Let's see what he did. The student measured the mass of 250 centimeter cube of the measuring cylinder, as shown in the figure 1.1. Then she pours the sand into the measuring cylinder and measure the mass of the measuring cylinder and the sand as shown in the figure. Yeah, first of all, at the beginning, we have the mass of 250 centimeter cube of the measuring cylinder. So this is the kind of the measuring cylinder, 250 centimeter cube. It doesn't mean he put mass of the water, no, just it's empty. So the mass without anything, it will be 56 gram. And then after adding the amount of sand, the mass will be 219. So now I need to calculate the mass of the sand only. So the mass of the sand will be, I'm going to subtract 219 minus 76 will be 143. Sure, I need to write the unit to check all of you if the unit is written or not. I have grams, so yes, the unit is written, so I'll take the mark. Then let's see the second one. The student measured the volume V1 of the sand in the measuring cylinder. Volume 1, 108. Now he tried to measure the volume. The volume, it was just 108. This is the volume of the sand. And then he asked you about what? I need to calculate the density. The density rho 1 equal the mass of the sand divided by the volume of the sand. So will be, as you see, we have this is the mass divided by the volume, which is V1, will be 1.39. If I need two significant figures, will be 1.3. If I need three significant figures, will be 1.32. This is G. It's not 139. This is 1.3 gram. Now, method number 2. Method number 1 is done. And we know the rho or the density of the sand in the first method will be 1.3 gram per centimeter cube. Now let's see the method number 2. We have measuring cylinder, we have water, we have the sand sample, all of them together as you see in front of you, and then the level of the water in this level. Okay. Let's read the method and let's see what happens. The student poured 100 centimeter cube of the water in the measuring cylinder containing the sample of the sand. يبقى now I have the sample of the sand, okay? And then I pour 100 centimeter cube of the water. I added on the sand. Sorry. Let's do it with another color. I pour 100 centimeter cube of the water on the sand. And this is the amount of sand, okay? Some of the water soaks into the sand sample and she waits for the water level to become constant. Okay. Record the reading V2 of the water level in the measuring cylinder. Now the volume, I can take the reading of the volume of the water. As you see, this is the level of the water will be. This is 150 and then this is 160. It means each one will be 2. 152, 154, 156, and so on. How can I calculate the scale? 160 minus 150 will be 10. 10 divided, how many slashes we have? We have 5, so each one will be 2. Okay, so now it will be 154. Then I need to calculate the density of the sand by using method number 2. Use the values from AI and BI and the equation rho 2 equal M divided by V2 minus K, where K is equal 100 centimeter cube. Yes, I know this equation is not included in our curriculum, but by the way, I said before in paper 6, we have equations are written by the way, and you have to follow the equation. That's it. So I need row 2. Let's see, M equal what? This is M, which is 143 in the previous page. And then V2, I got it at the beginning, which is 154. I'm going to substitute M 143 divided by V2 154 minus K, which is 100. The result will be 2.648. I needed two significant figures, so will be, if I needed two significant figures, would be 2.6. If I needed 4 rounded up, so will be 5, about 2.65 if I needed 3 significant figures. Okay? Now, according to these calculations, or according to this equation, I need what? I need the density of the sand only. يعني from this equation, I can get the density of the sand without water. Okay? Without water. يبقى now, sure, as you see in front of you, let's see which method it's more professional, it's perfect more. The first one, by just adding the sand, and then measure the mass of the sand, and then measure the volume of the sand, and then mass over volume to give me the density. But this calculation, I add water. And according to this equation, which is rho 2 equal m divided by v2 minus k, I can get the density of the mass only without anything. So let's see. He said, on the diagram, on the arrow, show the correct line of the side for reading the volume water in the measuring cylinder. As you know, we have, if I'm talking about the measuring cylinder all the time, we have the meniscus. We are going to take at the bottom of the meniscus, we can take the reading. First of all, you have to look perpendicular at the bottom of the meniscus. So I'm going to see the bottom of the curve and make a perpendicular line. So this is the correct reading. Now, let's see. Question C. Another student wants to determine the density of the particles in similar sample of the sand. The same, okay? Explain why method 1 wouldn't be a suitable method for him to use. The first one, we have sand. I said before we have sand only. This is method number 1. Method number 2, I add sand, and then I add water, and then according to the equation, this is method number 2, according to the equation, I can get the density of the sand only by removing, sure, anything related to the water according to the rule which is given. Now, in the sand particles, try to imagine with me, and then I have the sand particles now. Between the sand particles, we have what? We have air particles between them. So now we have air between, because we have gaps, as you know. We have gaps between the sand particles, so it's filled, all these gaps are filled with air. So I have sand and air. So now the total volume will be the volume of the air and the volume of the sand, not the sand only. Now, what about the second one? The second one, we have, yes, we have water, we have sand, but actually now the sand, we have, yes, the particles, as you see, but the water goes inside the sand to fill the gap between them, all of them. And according to the equation which is given, okay, I can take them, that I can get the density of the sand only without any water. هنا you have to know, and then I have the sand, the gaps between them is filled with water. But when I use the equation, خلاص, I am going to get the density of the density of the sand only without any amount of water. Okay, so which one of them is correct? The correct reading is, our correct method is the second one. يبقى now, explain method 1 wouldn't be suitable method for him to use. Why? Because the particles have large gap between them. So the total volume is the volume of the particles and the air which is filling the gap between the particles. Let's see method number 2 by using water would give a more accurate value for the density of the particles in the same sand. هو اللي قال, he said. يبقى you have to think about the suitable answer. The water displaced the air in the gaps. So the actual volume of the sand particles is calculated. Now I need just the actual sand particles. I'm not talking about the water. So it will be more accurate than the first one. Describe two possible sources of inaccuracy in the measurement taken in method 1 or method 2, even if they are carried out carefully. Carefully, it means I did my best. So I did my best, it means I put everything, I look perpendicular, I try to measure the mass and take care in the balance is horizontal to avoid any vibration. I take care of everything, all the precautions I did. Now, so the mistake will be in what? Maybe the devices or the equipment which I uses. Like maybe the sand surface is not flat. So if I put the sand surface is not flat, maybe by adding the water, it means we have a volume is more. So I have to make the surface of the sand is flat at the beginning and then add the water. So the level of the water now it will be, I can calculate the increase in the volume. 2, pan balance only to the nearest gram. To the nearest gram, this is one of the inaccuracy, or one of the sources of inaccuracy, because if I need it to the nearest gram, because the mass, for example, it's 2.2. How can I take to the nearest gram? يبقى 2 pan balance only to the nearest gram, because this is one of the precautions which we have to follow. One of the maybe it's wrong, maybe it's something wrong. Why? Because we need 4 milligram, because the reading it will not be only gram. This is gram and this is centigram, and this is, for example, if it's 1 it will be milligram. Every time if I just take to the nearest gram, maybe we have more than grams, maybe we have to the nearest milligram. So when I choose or select the balance which is the nearest milligram, I will be more precise and accurate. Then the measuring cylinder graduation too large. If I have a scale, if I have something graduated, it's better to be smaller graduation, because if it's, for example, 1, 2, 3, it means what about in between? We need just, it's like, as we said, to the nearest gram is wrong. We need to be the nearest milligram to be more precise. The same, the measuring cylinder graduation, it's too large. This is one of the sources which give me inaccurate reading. I need to make the graduation very little. Why? Because, for example, if the volume till this 1, for example, what should I do? How can I read? How can I take the reading? So we need it to be too smaller, not too large. يبقى now let's see 2 possible sources of inaccuracy in the measurements. First, maybe the sand surface not flat. 2, pan balance only to the nearest gram. Measuring cylinder graduation is too large. Now, experiment number 2 is related to the thermal physics. We have, let's see, a student investigates the cooling of the hot water in surroundings with different temperature. I have hot water and then the surrounding will be different. He uses the apparatus shown in figure 2.1. We have beaker A and we have lead. We have beaker B. We have bench, we have thermometer. The thermometer on a stand, as you see, it's more better and perfect to give me an accurate measurements for the thermometer. Now, let's see. The student pours 100 centimeter cube of the cold water in beaker B. I have beaker B. I pour 100 centimeter cube of water and place the thermometer in the water. Now place the thermometer, measure and record in the appropriate column heading of table 2.1 the temperature θ1 of the water as shown in the figure. I put the thermometer. After putting the thermometer, I can see the reading now. This will be, if I'm talking about the first reading, I have 10, sorry, and this is 15, and then 16, 17, 18. So will be 18. I go to the first heading, the table, sorry, and then put 18 in the table as you see. And the unit is written, by the way, I put 18. Now, let's see then what happens. The student places beaker A, I have beaker A now, inside beaker B, as shown in figure 2.3. So the water in beaker B rises between the two sides. Now, as you see, the water rises at the two sides. Just put beaker A in B. ده اللي عمل. Okay. And then he removes the lead. I remove the lead and pour 150 centimeter cube of the hot water in beaker A. I add 100 centimeter cube, 150, sorry, 150 centimeter cube of hot water in beaker E. He replaced the lead and put the thermometer into the hot water in beaker A, and then I put the thermometer. Okay. And he records in table 2.1 the temperature theta A for the water every 30 seconds. I'm going to take the temperature of the water every 30 seconds. يبقى now the first one, I have the water in beaker B, but the water in the beaker B is cold water. At the beginning, it was cold. And we have inside beaker E, we have hot water, which is 150 centimeter cube. And then I'm going to record the temperature every 30 seconds. The first question, describe one precaution that can be taken to ensure the temperature reading are as accurate as possible. I need to take the reading more accurate. I am taking the reading by using thermometer, and we have water. So what I have to do, look perpendicular to the scale. Why? To avoid any parallax error. Wait until the reading stop rising in the thermometer. Avoid the thermometer touching the beaker. If I want to, so we have a stand. If I want to put the thermometer, keep it away from the bottom of the beaker. Okay? If I want to take the reading, stop until the temperature stop rising. Wait until the temperature stop rising in the thermometer. All of these precautions are repeated every time in this kind of experiments. Now, the student repeat the process for the water at higher temperature theta 2 in the beaker B. What does it mean? Now, I said at the first one, we have two cases. The first one, I have beaker A inside beaker B. Now I have beaker A inside beaker B. What the difference between them? Both of them, yes, maybe A has hot water. A has hot water, it's okay. But B, the surrounding water at the beginning, it was cold. And then the surrounding water at the second experiment, it was hot. So this is the temperature, 18 or 48. It's the temperature in beaker B. So we can put one time, the first time, the beaker B, it was cold water, which is beaker A surrounds by cold water, which is the temperature is 18. And the second time, beaker A is surrounding by beaker the water, which is hot, which is the temperature 48 degrees Celsius. يبقى دي كانت 48 degrees Celsius, and this the first time it was 18 degrees Celsius. Now let's see the difference between them. يبقى هنا ال surrounding بتاعي هو اللي is different في ال two cases. يبقى the first one, the temperature it was 78.5 and the last one 62. So the dropping in the temperature 16.5. طب لما كان surrounding warm، لما كانت ال temperature 48، كان ال starting 80 initial temperature 80 and the last temperature of the final would be 70. So the dropping 10 degrees Celsius and هنا 16.5 degrees Celsius. Which one of them the rate of cooling is faster? The rate of cooling is faster in which one? It means إن أنا when I use the surrounding temperature is cold, it means now, as you see, the cooling rate is faster. The 16.5, the temperature has a lot dropping. لكن هنا just 10, it means هنا the rate of cooling is slower. طب let's see the question. He said what? Write a conclusion stating in what way the temperature of the water surrounding beaker A affected the rate of cooling of the hot water in beaker E. Justify your answer. I said before, if I need to justify my answer, I have to use the values or the result by mentioning the dropping in the temperature. He said what? خلينا to see answer. The lower the temperature of the water surrounding beaker A, the greater the rate of cooling. وده اللي حصل. كان in the first one في البرد كان surrounding temperature 18 degree. يبقى this is the lower temperature of the water surrounding. Surrounding يعني كانت موجودة في beaker B. surrounding beaker A يعني beaker A inside beaker B. فالsurrounding عندي is beaker B. الريت اوف كولينج يبقى the lower the temperature the greater the rate of cooling بدليل ان حصل dropping of temperature 16.5 degrees Celsius as when the temperature of the surrounding was 18 degrees Celsius. That how can I justify? You have to mention the dropping in the temperature. The temperature of the water beaker A dropped by 16.5 degrees Celsius during 180 seconds, while when the temperature of the water was 48 degrees Celsius, the temperature dropped by 10 degrees Celsius during the same time. يبقى the lower the temperature of the surrounding, the rate cooling will be greater. Why? Justify because the dropping of temperature in beaker in the first case when the surrounding temperature was 18 كان the dropping of temperature 16.5 while the dropping of the temperature when the temperature of the surrounding temperature was 48 degrees Celsius the dropping was 10 degrees Celsius. Okay. Now calculate the average and now I need the calculation for cooling rate. A cooling rate in the cold water, we have to focus on the cold water at the beginning, which is, it means in the temperature, the starting temperature, which is 78.5 and the final 62. This is A, theta is 0. It means at the time 0. A, theta A 180, it means when the time was 180. Okay, let's see. Now, so will be 78.5 minus 62. Let's see above. This is 78.5 when the time is 0. Now, when the time 180, the temperature was 62.5. اشمعنى ده? Because he said in the cold water. Divided by the total time, which is 180, the result will be 0.0916. If I needed two significant figures, will be 0.092. What about the unit? I said if I'm talking about the temperature above, we have temperature at the top, and then we have time at the bottom, the temperature degrees Celsius divided by the time, which is second. So the unit will be degrees Celsius per second. Another student repeat this experiment at the same room temperature. State two other variables she should control in order to obtain reading as close as possible to the reading. If I need control variable, the same volume of the water, the same starting temperature, the beaker, the same material of the beaker, the same thickness of the beaker, the same surface area of the beaker. All of them will be right. After 180 seconds, the student measured the temperature of the water surrounding A in the first experiment and find it's 49 degrees Celsius. يعني theta A, which, theta 1, it was 49. Now he repeats the experiment again. And he found the temperature theta 1 equal 49 degrees Celsius. It was what at the beginning? It was 18 degrees Celsius. Okay, and theta 2, it was 48 degrees Celsius. يبقى now, after repeating the experiment, the temperature completely changes. Instead of 18, will be 49. State the reason why this can affect the result of the investigation and suggest what the effect it has on the value of cooling rate. First, I have to state what's the reason why this can affect the result. How? Now we have something is different. When the temperature it was 18, the cooling rate was faster. طب now the temperature instead of 18 would be 49. So 49 is more than 48. It means theta 1 will be more theta 2. So what happens to the cooling rate? Now the cooling rate will be less or decreases. Because when the temperature 18, the cooling rate is faster because the difference in temperature is more. لكن now after now becomes 49, so the cooling rate becomes less because the difference in temperature is less. If the answer, the reason theta 1 now is 49 degrees Celsius is higher than theta 2, which is 48 degrees Celsius. What's the effect on the cooling rate? The value of R will decrease. R, which is the cooling rate. You suggest one change of the experiment to reduce the effect in F1. I need to reduce this effect if I need to reduce the decrease in the cooling rate. So I use what? Larger volume of the water. Use constant temperature water bath. Use constant temperature water bath. Yani if I have the water outside, this is the, I said we put beaker E and then beaker B, the temperature in between, keep it constant temperature. Instead of using beaker E, smaller volume of the water, I'm gonna to use larger volume of the water. Instead, for example, 150 centimeter cube of the water, I'm gonna to use 300 centimeter cube of the water. Because we said at the beginning, we have some ways to increase the rate of cooling, like starting higher temperature, use of the metal can instead of the beaker, lower the room temperature, use a fan and the large surface area of the container. But if I want to reduce the rate of loss of the thermal energy by insulating, by using lead, lower the starting temperature, smaller volume of the water, and smaller surface area. Now, if I need to reduce the rate of cooling, I will use a smaller volume of the water. But if I need to increase the rate of cooling, I will use larger volume of water. Okay? This is the tips and tricks which are related to thermal physics. Experiment number 3, the student determined the focal length of the converging lens. She uses the apparatus shown in figure 3.1. We have illuminated object, lamp, U, which is the distance between the center of the lens and the object, U, and then V, the distance between the center of the lens and the screen. Let's see the question. The student sets the distance U between illuminated object and the lens to 20 centimeter. Now we have the volume, the length of U, which is 20 centimeter, is constant now. She moves the screen. I move the screen back and forth until we take a sharp image. She then measure and record the table 3.1, the distance V. Now I am moving the screen back and forth to take a sharp and a clear image. After fixing the distance between the center of the lens and the object in a fixed distance, which is 20 centimeters, don't change all over the investigation, but I will move what? I will move a screen. Why? Because to take clear and sharp image, and then I'm gonna to measure V. This is the investigation. Describe a technique to obtain an image on the screen that's as sharp as possible. Now, as I said, if I want to get, this is the only technique which is related to how can I get a sharp and a clear image? By moving the screen back and forth. Move the screen back and forth slowly. Don't say the lens because we have fixed distance. He didn't change the distance U. He didn't change distance U. He will just moving the screen to obtain a clear image. So I will move slowly. I will move the screen slowly until obtaining clear and sharp image back and forth. Where the screen should be placed initially by moving the screen slowly. How an accurate position for the sharp image is obtained by movement back and forth. The first question he asked me to measure the distance, which is V, sorry. he said he said measure and record the distance V. I'm gonna use the ruler to measure the distance between them. It's a little bit, all the drawing is missing. I will remove everything. Now I am gonna to measure by using ruler, put the ruler closer to the screen and the lens and try to measure the distance between them. I'm not put it at the top, sure, I put it at the bottom, but just I am focusing on, you are going to measure the distance, which is V. And then record the reading in the table, which 0.33. This is, it's not the distance, this is U over V. After now, fixed distance U, 20, he measured V, which is 60. After measuring the distance U and V, he started to calculate U over V, so will be 20 over 60. The result will be 0.33. Now we have everything in the table is completed. We have the units, we have the readings, it's okay. Let's see what we need in the graph. First distance U20, calculate and record in table 3.1, the value U over V with it. Now, plot a graph, focus now on the graph. I need what on y-axis and I need what on the x-axis. I need U, which is the distance of the object or the distance between the object and the center of the lens, اللي هي اليو. اليونت centimeter, so I will write U slash centimeter. U over V, U over V ما فيهاش distance. Why? لأن اليو in centimeter, V in centimeter, remove both of them together. So it will be U over V without writing any units. Okay, U over V. Now, let's see the pattern and the scale. I have, by the way, as you see, if I'm talking about U, we have pattern. We have 20, 30, 40, 50, 60. So I'm going to start with 10, 20, 30, 40, 50, and 60. What about U? We need, we have 0.3, this is the least number, and we have 3, it's the biggest number. So I'm going to start with 0.5 and then 1, 1.5 to reaching 3. Let's see the scale. We have 0, 10, 20, 30, 40, 50, 60. On x-axis, I have 0.5, 1, 1.5, 2, 2.5, 3. Let's see the difference between the two numbers in the y-axis scale. We have 30 and the 20, the difference between them, 10. How many tiny squares between them? 10. So 10 divided by 10, it's 1. So each tiny square will be 1. So will be 20, 21, 22, 23, 24, 25, and so on. Let's see the scale on the x-axis. Now I have, this is 0.5, the difference between 0 and 0.5, it's 0.5 divided by how many square between them will be 10. So each tiny square will be 0.05. So each two will be 0.1. Okay? So you have to focus on the scale and how can I read my scale? After plotting the graph according to the points which we have above, I'm going to plot the graph between U and U over V. So I have this, you have to focus on, I need which one? I need U with U over V. I am going to focus on the two columns. After plotting, as you see, I'm going to show the line of best fit. Line of best fit, as much as you can, I said before, the line goes through the most of points, but you have to check if I have the points which are away from the line, as much as you can make both of them at the two sides are equal. The points at the two sides are equal. For example, I have just one, it means I have one under the line. If I have one above the line, it means I have one at the bottom of the line. If I have two, it means I have two under the line. If I have three above the line, it means I have three at the bottom of the line. Should be as much as we can equal. Now, a line of best fit, it means in a line go through the most points. مش لازم يجوين all the points. هو go through the most points. After doing the line, I need what? The gradient. Why? Because he asked me about this one. He said at the beginning, determine the value U node or U original of U when you divided V equals 0. يعني how can I get, now this is U over V. When U over V equals 0, U, it was what? It was the intercept. The intercept, will be 15. So I wrote 15 centimeter. Don't forget to write the unit because the unit is not written. The accepted value from 13 to 18. After that, he said the gradient of the graph is numerically equal to the focal length. Determine the value of the focal length of this experiment. Show clearly on the graph how you obtain the necessary information to determine the gradient. Now I need show on the graph. If he didn't ask you, draw it, by the way. If that in the question he didn't ask you, you have to show your work on the graph and to show your work on the graph, whatever he asked me or not. Now the gradient y2 minus y1 divided by x2 minus x1. I said before the graph should be, as we said, GG. What does it mean, GG? G stands for graph. Line graph should be more than 50%, from the page. As well, the gradient should be, if I'm talking about the gradient, should be more than 50% from the line. Now I choose a bigger triangle, which is more than 50%. We have 2.60 with 3, and I selected 20 with 0.33. So after writing and substituting 60 minus 30 divided by 3 minus 0.33, this is the answer. And now I have to make at least 2 significant figures, maximum 3 significant figures. So I have 11.2 with the 3 significant figures. So just one precaution that can be taken to ensure the measurements are accurate. How can I make the measurements accurate? Mark base of the lens, because we said if I'm talking about the lens, we need to ensure every time this is from the center. So we have holder, and I have to mark the holder in the middle. So mark the base of the lens. Clamp the ruler to the bench. I have to clamp the ruler to the bench. What does it mean? Fix it or tape it. يعني just to make it more tight. Lens and the screen upright. I have to check they are upright and vertical. Darkened room and brighter. We can write brighter object and darkened room. Now, this is the precautions I said before to take an accurate reading. We can use dark room and the brighter object. Mark the position, the center of the lens in holder, as you see on the holder of the lens. We can ensure the center of the lens at the same height. We have the screen, the lens, the object, all of them are the same height. Repeat and take an average. Moving the screen left and right, moving the screen left and right to take a sharp image. And this is specifically for the sharp image, not the reading. This is for the sharp image. Now we have the screen and the lens and the object, all of them at angle 90. So all of these precautions you have to follow while I'm asking about the image, or if I need clear image, or I need the precautions for the reading. Now the last investigation or the last experiment which we have related to the plan investigation. Let's say a student investigate the brightness of the lamp. Plan an experiment to investigate how the intensity or the brightness of the light produced by the lamp is affected by the current in the lamp. Now I have to focus on the independent variable and dependent. What's the changing? I need the change that happens, the change that I need to change to measure something. I change what? I change the current, and according to the current, I'm going to measure the brightness or the intensity of the lamp. So independent variable, the variable that it changes will be the current. Dependent variable, the variable that measures, it's the intensity of the lamp. I have the apparatus. I have lamp, power supply, light meter to measure the intensity. We have an ammeter to measure the current. I have variable resistor to change the current. Now, focus on, in your plan, focus on what's the following. Number 1, 2, 3, 4, 5. We need to complete 5 orders to take the reading or to take the mark. Complete the circuit diagram by using variable resistor connected to the control current in the lamp. Number 2, state the key variables to keep it constant. Explain briefly, it means I need the steps. I have to draw a table, and inside the table, I have to ensure we have the x-axis and y-axis. X-axis, which is the independent variable, y-axis, which is the dependent variable. The last, explain how to use the reading to reach a conclusion. If I am asking you how to reach a conclusion, you have to say all the time, plot a graph and mention with x-axis and mention its name, and y-axis and mention its name. دايما all the time, always ask you the question, how to reach a conclusion. You have to write the same sentence every time by changing the name of x and the name of y. Now I put variable resistor and complete the electric circuit to achieve the first order or to achieve the first statement. I put the variable resistor. You have to focus on the variable resistor diagram. The variable resistor will be rectangle, and inside we have arrow. Measure intensity of the lamp. This is the light meter to measure the intensity of the lamp, and then the circuit is completed. So I will write in the investigation at the beginning, yes, you have to set up the experiment as shown in the diagram. And then I will do what? First of all, let's see. I fix the light meter in front of the lamp will be all the time fixed distance, which for example 20 centimeters. Then what should I do? I change the variable resistor. I will change the variable resistor. After changing the variable resistor, what happens? Now I measure the current, so I have a current. And then after taking the current, it means I change the variable, current. Now it changes. I will measure the intensity of the lamp. Then I change the variable resistor, another reading. The current changes as well. So I will record the reading. I'll measure the light intensity by using light meter. Number 3, I change the variable resistor. What happened? The current changes as well. So I have another reading of the current and then measure the light intensity by using light meter. I didn't change the distance. What I'm changing, I'm changing the current. By using what? By using a variable resistor. Sorry for everything. It's a little bit messy. Now, so let's see the steps. I have to mention at least 5 values of the current. I have to mention I will use what to measure. يبقى now set up the experiment as shown in the diagram. Place the light meter at the distance 20 centimeters from the lamp, and this is one of the constant variable which I have. Then close the circuit and change the variable resistor. After changing the variable resistor, record the reading of the ammeter, which is 5 ampere. يبقى أنا عملت changing. أخلي الكرنت بتاعي 5 ampere. This is the starting. And then measure the light intensity by using light meter. I mentioned the measurements. I mentioned the tools. Repeat. We said before M, R, R. What does it mean? M, it means measure. R, it means repeat. R, it means record. I have to record the readings in the table. R, I have to repeat and take an average. M, it means measure. I have to use the suitable verb. Measure the light intensity by using light meter. Repeat with the steps with different currents, 10, 15, 20, 25. لازم يكون values عندي at least 5 values. Number 2, we have pattern between the values. Record the result in the table, repeat, and take an average. Now, the last question, when I ask you how to reach a conclusion, I said what? Plot the graph and mention the x-axis and the y-axis. Yes, now, question, the last one, this is for the last question, or the last order, or the last requirement. Plot the graph with current on the x-axis and the light intensity on the y-axis. Control variable, we have the distance between the lamp and the light meter. I said that, which is we did it before, 20 centimeters. The light intensity in the surrounding. If I sit, for example, in the dark room, I will sit in the dark room. If I sit in the room with specific light intensity, I have to be all the time in the same room. Don't change the room because the light intensity sure will be affected. Now I have the table because he asked me to draw the table. I said before, as we have the graph, we have x and y, independent variable and dependent variable. On the graph, the same, we have x and y. The x will be independent variable and the y will be dependent variable. Like the graph, the same like the table. So I have ampere. This is current, I current slash ampere. I have to mention the unit. Light intensity. And we have a unit which is lux, but it's not important to write the unit because you don't know, it's not familiar for you. It's lux. And the light intensity on the y-axis, this is x-axis and this is y. So the y-axis will be the same, light intensity, and the x-axis will be the current slash ampere, the current in ampere. And now October, November 2023, variant 3 is done. Love you all. Thank you.